Yeah, go for it, Dan.
Right, I got the unenviable person in the way of lunch slot, so you know, you guys having lunch already early preemptively, it's all right. Hi everybody. Some of you know me. I've been part of London VMUG since 2012, I think was the first one I came to. My name's Sam McGeown, and I currently work for HashiCorp, an IBM company, as a developer advocate. I work across all of our infrastructure and automation security products. But my background is firmly VMware. I worked at VMware in various roles for 7 years. So ranging from consultant, NSX consultant, automation consultant, technical marketing, and even a product manager for a couple of years. So I've been in the VMware ecosystem for a very long time. So I always have a soft spot for VMware, and especially automation on VMware platforms. So today I'm going to talk to you guys about how to supercharge VMware automation with Terraform and AI. Now I know that you get the buzzword AI slapped on every conference and every talk these days. It is all over the place. Show of hands, who's actually using an LLM, ChatGPT, or Claude, or something to help you write code in your kind of day job at the moment? Yes, yeah. So there's a few people. I'd say that's probably a "I'm dabbling" response, right? People are kicking the tires with it a little bit. What a lot of people will find is they start to maybe if they're actually, let's have the other question. Is anyone using Terraform to manage their environments? We have some Terraform users, which is fantastic. If you're not familiar with Terraform is basically infrastructure as code. It allows you to define environments, including your VMware environment, as a set of code files in HashiCorp configuration language, and then you plan and apply that code against your environment, and Terraform will go out and make sure your environment looks as it's defined in your configuration file. And I'm not going to go into all the advantages of infrastructure as code now. There are lots of them, but that is kind of Terraform in a nutshell. Because it's in code, we can use tools like Claude AI, or we can use Copilot, which is one I use quite heavily, using those assistants to write that code for us, which is great, and it's really helpful, and quite often will write you code that doesn't quite do what you want it to do, or maybe uses a version of the provider that doesn't exist, or hallucinates slightly and gives you something that you, as a human being, then will need to go in and review. So these things can be very, very helpful. They can also be not so helpful at times. And this is where part of what I'm going to talk about today comes in, and that is an MCP server. What the heck's an MCP server? So Model Context Protocol is MCP, and you can look it up on modelcontextprotocol.io, but basically you think of it as USB-C for your AI applications. So it's a way for you to plug your LLM, your chatbot, in your AI system into another system. So you can define sets of tools, you can define resources, you can define the other thing, the third word that I never use, so I always forget what it is. It's on a slide in a second, but you can define these sets of tools, resources, and I'm going to skip forward. Prompts, that's it, on an MCP, and that will allow you to provide information to your LLM without necessarily having to go through training. So you could train an LLM on a set of documents, and you could build a model that had that knowledge baked into it. That's great. The problem then is it's only as good as your latest version that you've trained it on. You can also use something called retrieval augmented generation, which allows you to retrieve information and again generate based on that information, and that is a good approach for a lot of things. You need someone who is experienced and available to actually do that for you. It's not something that's easily accessible to everybody, and certainly if you're managing your VMware environment, do you really want to go down the route of learning how to build and manage a RAG? Probably not. So what MCP servers allow you to do is have a standardized protocol that exposes standardized tools and standardized resources and standardized prompts, and we'll jump forward just here, to then allow your LLM to utilize those, and that means you can plug it into your own documentation or your own APIs or your own methods. So when we have an MCP server, we talk about the MCP client or the MCP host. That typically is like your Claude AI or your Claude Code or your Visual Studio Code, where you're running that chat interface with a model, and that will connect to your MCP server, and that's basically a very small application that's running in Docker, or it might be running as a binary, or you can even sort of compile it from code if you want, if you're a narcissist and a masochist and all that thing. But you configure your host to communicate with your MCP server over a JSON RPC channel, and then that MCP server exposes tools. So that's executable functions. So it might be something like list all of the providers that are available. I'm going to talk in the context of Terraform. Terraform will allow you to list all the providers that are available, get all the latest versions of a particular provider. There are a whole bunch of tools that are exposed. But also, it might be that you've got an internal API that you've written an MCP server for, and it allows you to expose functionality of that API to your LLM. Similarly, resources are things like you might expose documentation. So for us at Terraform, we are exposing things like the style guide, which gives you pointers about the best practices and the way to write your Terraform code. Then the last one is prompts, and this is more than just a simple function. This is like chains of functions tied together. This is more complex interactions. The majority of things that you see these days are exposed via tools. You'll see a few resources. You don't often see that many prompts being exposed. But that is effectively what the MCP server does and how it works. For the Terraform MCP server, effectively you have your developer workstation might be sat there, someone's typing away in code or Claude, and it spins up for you dynamically a Docker container with the MCP server, and that MCP server will expose by default access to the public registry, so where all the Terraform providers are, and as I mentioned before, the style guides and something called the module development guide. So if you just out of the box spin that up, you don't need any licensing or anything, it's all the community edition of everything. You can actually augment your LLM to get the latest versions of publicly available modules. So you could say, get me the latest vSphere or VMware management module, and it'll provider, and it will go out, it will find your latest version, and it will start writing you code for that. The advantage with that is you can also create instructions for your LLM. So most LLMs will allow you to have a bunch of static instructions that you put into an instruction file. So you could say, like, talk like a pirate, and it will always talk like a pirate because it will preload these instructions. You can say to it, always use the MCP server when you're trying to write Terraform code, and use the style guide that's available as your guide, and it will automatically use that to help you write better, cleaner code for it. But what you can also do, and I have no sales, but you can also, if you are a Terraform Enterprise or a HCP, so HashiCorp Cloud Platform Terraform customer, you can have private registries, and within those you have your own private providers that are written for your company, and you can start also having that functionality of being able to create workspaces and variables and runs within that platform. So HCP or Terraform Enterprise is it adds a whole bunch of functionality around Terraform, which you can use, and I'm not going to try and sell that now, but it's got a whole bunch more functionality. And so if you provide it with an API key, you can then start working directly on your platform. So you can say, list me all the workspaces that are available in my cloud platform, and it will list those workspaces, or create a set of variables for me, and it will create those variables so that when your code runs, those variables are substituted in, and it will execute code. And your end result, your infrastructure that you're deploying, say an application on vSphere, or some, a VCF. There's a VCF provider, so you could be deploying a VCF platform. Will be configured to look like the code with the input of the variables, and then you get your environment at the end. You can also, with an MCP server, and this is, I just say this now, this is my last slide. After this, we're just going to look at some actual demo stuff and a bit more interesting. So, promise the last slide. You can also run MCP servers as an external service, and this is really important because it's all well and good you having an MCP server on your local laptop running as a little Docker container, and all your developers are doing that. That's great. But what happens, how do you manage the security around that? Each developer's got their own access key that they're using to access your environment, or how do you ensure the right people are accessing the right place? It becomes a little bit of an interesting topic. There's also things like scalability. How do you want every single developer running an MCP server on every single laptop? All those sort of things. So what you can do actually is run that Docker container as a service somewhere on Kubernetes cluster, or you can run those binaries on a virtual machine if you want, and provide a service that will scale and allow you to put all the governance around it that you would expect from like an enterprise platform. And what that would allow you to do is actually have multiple developers accessing that MCP server, and then you're gating your access to your environments through that server. So your API keys, for example, can be specific. You can have enterprise authentication. You can have SSL in front of it with your secure traffic. So when you create a remote MCP server, it's the same communication protocol as JSON, RPC over HTTPS or HTTP. But it also allows you to do things like plug in your LLMs into your CI/CD pipeline. So you could go for, if someone was committing your infrastructure as code to a repository, it triggers a pipeline run. That pipeline can then use the LLM to do a code review on it for you and give you it could look for security issues or style issues or something like that. So you can then use the MCP server for your pipelines, or for agents running within your workflows if you're using AI agents. So all of this is great kind of theory stuff, but as I promised, that was the last slide. We'll do a little demo and we'll have a look at how does this actually work for someone. So I'm going to sit down because my typing standing up and bent over is less fun. So I will sit down here, and I'll come out of this, and let's switch to screen mirroring. Let's go. Start mirroring. Cool. Okay. So I'm going to switch over to Visual Studio Code. So within VS Code, there are a couple of things that I have configured here. So I have my account logged into GitHub, so I can use Copilot, and I've switched Copilot to run in agent mode, and that's important because that means I can now use tools with my agent. But right now, nothing's configured. I have a couple of files. Well, I've got a folder.github, which I'll move this file into in a minute, and this is my instructions file, which allows me to tell the LLM what I want it to do. And then I have this .vscode file, and this is the one I have open. Within there, there's an MCP configuration, and this is where I configure how I'm going to get the Docker container running, or the container running with my MCP server. So the simplest way to run is to simply have a little configuration stanza here, and I'm telling it I'm going to run a command. It's a Docker command. I'm going to run interactively, so we want to be able to send commands to and receive output from. When it stops, we're going to remove it because you don't want to leave a whole bunch of containers sort of hanging over. And then I'm running the latest version of the Terraform MCP server. And that's all I'm telling it to do. So right now, if I was to ask the agent, I would say, write me some Terraform code to deploy a 3-tier application on vSphere. You should use new NSX segments behind a load balancer for the web tier and a database server, and I want you to create some rules, firewall rules to stop anything else accessing port 3306 on the database. So I could do that right now, and you would get a best effort. So the model I'm using here is, for example, is Claude Sonnet, and Sonnet's pretty good. It would give you a pretty good estimation of what you wanted. You'd probably look at it if you were reviewing it and you go, okay, that's not quite right. It's not used quite the most latest information there, or it's not used the latest API versions, etc. You probably won't get the consistency in terms of how the code's written, because it's learned on other code bases. You might get a sort of mismatch of different ways of doing it. With the MCP server, you know that it's going to go out and it's automatically going to go and look for the latest available provider. It's going to use the APIs that are the most recent, and it's going, or if you wanted, you could say use this specific provider version at these specific levels. And so you can tell it, I've actually got vSphere 8, so you only use APIs that are available within vSphere 8. But the point is that it gives you that control and that certainty that the latest source of information is going to be through the MCP server. So once I've configured and saved this little stanza here, all of a sudden in code you get this little start button up here, and there's a little more, and I can hit start, and actually what's happening in the background is if I do a Docker PS, we can see that we've just started that container. And you can see here I've got some stuff commented out, and that's basically because this is running without any configuration, any enterprise features. This is just how you could use it if you're using Terraform Community Edition. And you'll see here there are 9 tools available, and we can actually go and say what tools are available in the Terraform MCP server, and the LLM will go out, and you can see it will ask in a second, because I've reviewed it, it'll say I'm going to go out and query what tools are available on this MCP server. So it's then listing what's available, and then it's actually also saying there are some enterprise ones. So these are the public registry ones that are always available, and then if you've got a Terraform Enterprise or Cloud token, you're also going to get various other things. But right now you can do these tools, get the latest provider version, get the capabilities, get the details, get documentation, search, grab modules, and then you can also ask it what resources are available, and it'll tell you there's a design guide and everything. You could also run it using Podman, another container management on your local desktop. You could also run it using Apple's container commands, which are, again, another local way of running containers. This stanza is actually a remote instance I have running on my lab at home, and that's just doing it over HTTP. It's got an ingress in front of it, with DNSs and SSL and authentication and all that sort of stuff. And so it'll use OAuth and identify who I am first. So these are the various ways of kind of running that MCP server locally. I'm not going to try and connect to that because I'm not entirely confident that I exposed that via my VPN. It'll probably fail horribly. So that's how you're getting your MCP to run. Let's get it to actually write us some code. So I like what I've done when I've done this talk before is let's grab some ideas, right, from people. If you were deploying something to vSphere, what parameters would you be looking at? If you're deploying an application, maybe you would be looking at, give me the template that you're going to use, maybe some tiers of an application, maybe some networking rules for NSX. You might be adding tags to virtual machines. There are all sorts of things you could ask it to do. So we can just make this up on the fly, basically. So I can tell it I want to deploy a multi-tiered application, if I can spell, on vSphere. Let's create a module. So a module is a way of encapsulating a whole bunch of configuration in a repeatable fashion. So you might have a module for a particular application, and that module might deploy your VMs, your networks, and everything wrapped in one. So I'm going to tell it to create a module. So a module that deploys, let's say two tiers, a web server and a database server tier. Use the Ubuntu 2404 template and create 3 web servers. Any other requirements anyone want to shout out?
One database.
One database server. What about the networking requirements?
2 segments.
Tier
1 router.
2 NSX network segments and a tier 1 router. Let's have a firewall rule in between.
Only allow the firewall rule. Yeah, between the web service and
so only allow, let's say, MySQL traffic between the web tier and the database tier. So let's do that and see how we get on, because you can always modify it later, but it also might take a long time if we keep adding requirements. I made that mistake. I did this presentation last night for a webinar, and I'd made the mistake of taking like loads and loads of requirements, and so we were building like landing zones in AWS, GCP, Azure, and all this sort of thing. And it suddenly went from being a demo that takes a few minutes at most to a demo that was thinking for a long time, exhausting all my tokens. Okay, so we can see that we've got some prompts. Now, ordinarily, you can allow all these things to happen in the background. I've not, it's just so I can talk through what's happening here. But we can see here we've got a tool result. So it's gone and it's used the tool to query what the latest vSphere provider is. So we're going to go and allow that. We've got another vSphere one here, or probably NSX, I think there.
Is it an NSX provider as well?
Yeah.
Okay.
And then there's another result, which is get the capabilities. So it's looking at what capabilities are being provided. So you can see here, it's telling you it's gone out to the MCP server for all of these bits of information. So I'm going to allow without reviewing this session. Hopefully that'll stop me having to click it so many times. So it's going back out and it's making specific JSON queries to that MCP server. And one of the advantages of this is it actually, if you're paying for context within your LLM, you're using tokens every time you build a query. And the bigger the query gets and the more context that you're using, the quicker you're going to burn through your tokens. So if you're getting very, very specific versions and specific responses, you're not going out broadly and saying, find me code for NSX to do this. You're saying, find me the specific code that is available through this MCP server, and then we'll do it. So the actual context reduces, and you can make more efficient queries. So right now, we're working through a little list of to-dos that's been created by the LLM, and so it's starting to think about the structure of how it's creating this. It started to create a variables file for inputs. It is actually taking a long time to do that, which is nice. But you can see here it's going creating it with a VM and network resources, and if
It's quicker than me writing the code.
it's a lot quicker than, and this is where it's really quick to start bootstrapping an environment, and you want to start, there's also, for example, we're at OVH, right? There's an OVH provider, and you can go out and say, I want to deploy this application on OVH Cloud, so set up for me in OVH Cloud the vSphere environment with this many servers, and you can actually configure OVH Cloud as your infrastructure underneath, and then deploy your application through your module directly onto OVH Cloud, and that will, that's the power of Terraform, because then you could say, okay, I've got my on-premises data center, and you deploy that module on my vSphere environment, and it will deploy that application for you. But you can also say deploy that application as well on my OVH environment, and you know that you're going to get a consistent deployment of that in as much as it is captured by your infrastructure as code. So we are chugging away generating configuration, 658 lines so far. So what we've got here, we're nearly there. Oh, it's also going to create.
What would happen in a scenario where, a bit like VPCs, right? So VPCs have come out for NSX, but the provider isn't up to date.
Yeah.
But you've asked it to create a VPC. Would it complain and say, well, I don't have it, it's not available in the provider, or?
It depends. If the provider doesn't have that functionality, the MCP server will go out, it'll look at it, it'll look at the functionality that's been advertised by that provider, and it will say, actually, there isn't a provider for a VPC. What will probably happen is the LLM will then have a kind of best effort guess at, okay, I'm going to try and create a VPC-like environment then. So you see that when if you ask it to create landing zones, for example, that's a concept that is out there where you have those consistent environments across multiple different clouds, and so it will try and create a landing zone within vSphere. Okay, so we've worked our way through the to-dos, and it's telling you this is what we got. This is what we got. Our next steps to create environment variables, give it all the credentials to our vSphere environment, and then Terraform init, which is to go and grab all the providers and collect them locally. Terraform plan, which is to then create a plan of how it's going to make those entities available, and Terraform apply, which would be to actually make the API calls to deploy all of these things. I have to tell you that my lab environment will not deploy all this in any timely fashion, so I'm not actually going to do an apply here, which is a bit of a cheat, but it works really well for me if I do it on an AWS environment, because I know that the resources are there and I can spin it down afterwards. In a vSphere environment, you've obviously got to make sure that your underlying infrastructure is available. I think so now we've got a little bit of code here, we'll have a look at this instructions file. So here, this is an instructions file that we've provided from a Git repo with the MCP server. So it's going to say things like, we want you to generate accurate, compliant, and up-to-date Terraform code. It's going to say things like using security best practices, organizational policies. This instructions file here is generic across, like most LLMs will allow you to supply instructions to them, and this will allow you to kind of give it your own flavor. So if you want to configure everything in the smallest possible unit and have a separate file for every smallest possible unit of code, it'll do that for you. You'd specify it here and say only create one entity within the file, name that file by the entity, and break it apart as much as possible. Or you could say, I only ever want one file that configures this entire thing, and it will compress it all together. So stylistically, this is you giving it standing orders effectively. So as I mentioned before, my favourite example of that is to say, you always talk like a pirate, and then I can save that, and you dump that within GitHub. You dump that within a .github file, and so you can set this generically across your entire Visual Studio Code profile. I don't do that specifically because if I've got an MCP server and a profile for a particular workspace, I might be working on Terraform code here, but I might actually write, I don't know, some Golang in another one. And so I'm going to use a Golang MCP server, and I'm going to use instructions that are specific to that language or that environment. So I like to keep it all within this particular environment. So we've got all my instructions now here, and then if we ask it to do something else, let's say review the code you've generated with the new instructions file in, I'm going to explicitly say in the code pilot.
So if you did the apply and it failed,
yeah.
would you ask, do you know what I mean, for it to rectify the code for you, or would you have to try and fault find it and figure out what was wrong with it?
So yeah, the simplest thing to do, right, is now talking like a pirate. The simplest thing to do, right, is you see the output in. So I might in my terminal go Terraform plan, and the code fails. There's a problem with it. I would just literally say to it, the plan has failed.
Yeah.
Read the output. But I don't even have to say to read the output. I'd say the plan has failed. What's gone wrong? And it will look at the execution from the context of my VS Code. So it will look at the terminal where it's got that output and the error messages, and it will say, oh yeah, right, okay, I see the problem, and it will start reiterating on the code. So I mean, you see that more in your maybe like programming applications. So one of the things I'm playing around with at the moment is using it to create an application, a spelling application for my kids. Because kids hate doing spelling tests, but they do like playing computer games. So if I can gamify it, that's great. I'm not a Golang programmer, right? So I'm using Claude code in this case to start iterating and say, okay, I want to add this feature, and I want to play a different game with it, and I want to do Hangman, or I want to do fill in the blanks or whatever. So yeah, it's less of like it's doing it for you, and more of like it's helping you along the way. But you can have that back and forth with saying, okay, yeah, this error message failed, or even you could say, right, I've tried to deploy it. I've got this error message on my VMware environment. What's gone wrong? And it will analyse from your error messages. And I'd say 90% of the time, especially with Claude Code, which seems to have a better understanding of the whole context. There are other ones like I use ChatGPT and I've used Grok, and a lot of them don't seem to take in the entire context. So the code that I'm using, and the environment that I'm using, and where I'm deploying it. Claude is pretty good at doing that, so I use Claude Sonnet as a general rule. If I want to get it to plan loads of stuff, you can use like Claude Opus, which is better at it. It's more expensive to run in terms of tokens, but it will plan a much more comprehensive plan, and then you can go, okay, right, now take that plan and use Claude Sonnet to actually implement it. So you can be a bit savvy about which models you're using for which part of the planning. So now my pilot assistant here has gone through, and I've told it using the Copilot instructions certain things, like to use the style guide to check against best practices, look at maybe change the module structure, so it's create some test files, it's created some examples, we've gone and actually gone through and done a compliance checklist and things like that. So it's got all the files, it's got the latest version of providers, it's got back-end configuration, all these things that it's been told from the instructions file to do. So that means that we now have, I'm going to get rid of the pirate bit, but the code is fully compliant. So right now this module should, in theory, if I provide it with the variables that it's asking for, so we're looking at, for example, like the template name, the CIDR for the segment, maybe like number of web tier, CPU count, all this sort of thing. These are all the inputs that are going into the code. And so if I was to add those variables to my variable file, execute the plan, it should go out and do it. As I say, my vSphere environment is, well, it's creaking a little bit, so let's, I'm not going to run it against the lab. The other thing I will just quickly show you, because it is quite a cool feature of it, is if I take out this part of it, and so I'm now providing it with a Terraform enterprise token, which just jump in to the right one. This one. No. Maybe I'm not going to get here. Okay, so I've got this is my Terraform Cloud environment. Within there, I've got some workspaces, and within there, I've got this workspace for the MCP demo. I actually need to just quickly give an API token. I'm going to generate an API token which will last for an hour. And the reason I'm doing that is because it's only going to last for an hour. But I don't want to put in a long-lived one that everyone can see. So I'm going to say, create me a new token with access to my team. It's going to give me that token. Okay, so now in my configuration for my MCP server, it's actually already got a token, but that's the token I generated last night for an hour, and so it's expired. So we just get errors if I did that. So I'm going to save that configuration. I'm going to provide an environment variable with the token to my my container, and I'm going to restart that. And so it should be prompting me for password. Yeah, there you go. It's always one. Let's try that again. So if I start that, it's now prompting me for my API token, which I'm going to give it. And then we have here, it's discovered now 34 tools rather than 9 tools it was before, and that's because we now have access to a bunch of tools in my enterprise environment, or my cloud environment, including being able to create variable sets for my workspace. So if I want to now create a new workspace called MCP-vSphere, it should now create me a workspace, and I've not told it in HashiCorp Cloud, I've not told it any particular things. It's going to see the keyword workspace, and it's going to select a tool, hopefully. Yeah, there we go. No, it's not. It's going to create a workspace within VS Code, because it's going to first see the VS Code one. So let's not do that. Ignore me. So when it was having to think, and it went through this optimizing tool selection, it went through and it looked for a keyword workspace, and perhaps that was a bad choice on my behalf, because VS Code calls it a workspace, and so it's gone for the VS Code one first. So I need to be slightly more specific. Okay, so let's do list what Terraform workspaces are available. So it's using the Terraform token, and it's going to try and query this. And so this becomes, rather than just generating the code for you, it becomes something that you can use to do operations within your environment. So within with the code we've got now, I can use Terraform plan, Terraform, I can use the command lines to deploy it, and that's fine. Everyone can do that with the Community Edition. With the Cloud Edition, or the Enterprise Edition or Cloud, I can attach that to my my GitHub repository, and then we can trigger runs whenever I commit to my, so you get a kind of GitOps approach to it. But now I can also start triggering runs from my LLM, so it becomes an assistant to me as well in terms of actually operating and managing the environment that I'm working on. It still thinks I want to create a let's try that again. Let's say Terraform, HCP Terraform. It's funny how something that worked last night isn't working today, is it? The demo gods. So it's using the Terraform MCP server. it is also still talking like a pirate. I've done that. Okay, I'm going to abandon that here because that's probably going to take me a little while to figure out why it's doing that. Does anyone have any questions, observations, thoughts, any comments, anything they'd like to say?
Just to start, is it still talking like a pirate? Yeah. You haven't told it not to talk like it, but you just...
commented out the line saying, or deleted the line saying, talk like a pirate.
Yeah.
But it's now got free will to make its own choice of language, and it said, well, I quite enjoy talking. So
Yeah, it's going on basically the last instruction it had. So it's loaded a context, and within that context, it was told to talk like a pirate. So I can tell if I tell it it's like reload the instructions file, it'll go. I know what I want to reread the Copilot instructions file. It's done that. Hi, Captain. I see you've removed the pirate talk environment. No more ahoy matey for me. I'm now your professional Terraform, blah, 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 blah. So it's gone and reloaded that context, and now it should talk like that. Ordinarily, that is not something that you're going to kind of be changing mid process. It's something that it would load when you start your interactions in the context that you're in. It's just because I'm being silly with it and loading pirate talk. Yeah. So there is now quite recently. I think William Lamb put a blog post out recently about the VCF9 provider. So you can actually start configuring your VCF9 environments using Terraform, and so if, for example, you're building out a lab, you can actually have that configuration and get Terraform to push out VCF9, assuming you have licensing and access to the binaries and all that sort of stuff. But otherwise, yeah, there's VCF providers, NSX providers, but it becomes more powerful when you actually start deploying across multiple clouds and multiple environments. When you're getting consistent replication across different data centers and things like that as well. So hopefully that's useful. It is MCP itself is kind of quite a new thing. Obviously all the whole AI boom and everything. MCP seems to be a kind of standardizing way of providing instructions into your LLMs. Hopefully that is useful. Something you can at least say, if you're asked by your boss, I know about that a bit now.
Yeah, from my perspective, I think it's great actually, because we, Andy and I run the NSX, or what was the NSX experience days. Mm-hmm. So for a day, do you know what I mean, we used to get people to also manually create everything, right? Touch the VM to a T1, T0, did BGP peerings, all that. And then at the end of the day, we would run a Terraform script that basically created a whole environment that they just spent, for me, 7 or 8 hours doing in 5 minutes. So I created that Terraform script, which is in manual, it was sort of extending and borrowing the information, and actually just looking at that and actually realizing that a lot of that pain can be taken away, right? Well, obviously, it's fine, but so it's something actually we probably want to reintroduce, because ultimately the drive from our perspective with sort of VCF networking is to educate, networking people and actually simplify the deployment of networks, like to do it in physical, do it in the virtual, and actually abstract away from what they've been doing and actually deliver it in code. So actually we show you that actually there's a simple way of doing it, there's something way of doing it. I'd love.
Yeah, so we do a similar sort of thing with AWS game days. So we spin up, if we know there's like 45 participants for game day, we actually spin up 45 individual AWS accounts and the infrastructure for the game day, and then it's basically a sort of learning gamification of a thing. So it's a very similar sort of thing. But yeah, that's something that we can spin up, and we just have a module that is the game day module, and we can literally just leap through and say generate 45 new environments, and it will stamp each one of them out. They're all identical, and as long if one succeeds, they'll all succeed, and it's very, very easy to create those environments. I used to do when I was technical marketing for what was area automation. We used to do a similar sort of thing, but we had a pipeline that we ran, and like running that pipeline on repeat for it used to take a really long time, and you could have one pipeline succeed and one pipeline fail, and you've got to go and troubleshoot and everything. So yeah, the consistency you can get with it is fantastic.
That's good. Curious, we've got you've got that scientific came recently because we've got the AI team. Yeah, and those recently implemented that. I love the natural language. This is going to tell exactly what I know in the short. That's the way you prep for road to really go down in regards to. I know it's the more justice tradition. This is exactly like you said. The time I build a part, I can use that. Yeah, it allows me to natural language them instead of having to type in new lines of code or before it's done big code. Yeah, it's something that this don't read with it. Yeah, so the industry's not got a lot of that. No.
Considering how far it's come along as well, and the ability to grab the latest information with any is really huge. Like I could literally, I mean, I've used OVH many years ago to do some marketing stuff. But I could literally tell it, okay, I want to move everything to OVH Cloud, spin me up an environment that is suitable to host my application, and it will go out and find the provider, it will go and say what you need, it will look at it, and it will look at the documentation, and it will build that for you. And I don't have to know anything about OVH Cloud at that point. It's a force multiplier for sure. Cool.
Thank you.
Thank you.